Hello everyone. So as the third part of the Combat AI system tutorial series, let's discuss about enemy neutral AI behaviors. Right. So today we are going to cover the navigation volumes that we use at the Combat AI system. So these navigation volumes actually will be used to determine the specific area or a specific path where NPC can navigate. And then let's look at some of the core neutral AI behaviors such as idle or stationary state and free roam and roam in nearest bounding box and finally spline path following. So for example, like when it comes to implementing such as patrolling behaviors, this spline path following can be used. Okay, so without further ado, let's go for the implementation and see how we can actually implement those stuff in your project by using combat system features. Right. So here I've been open my project that I worked before. So currently I'm in map test enemy level, and here you can see I have added this enemy character in the previous tutorial, but I think since this is focusing a new feature, I'll delete this one and this one, and I'll show you how we can add neutral enemy AI behaviors in your game. Right. So you can see actually the navigation volume is also highlighted. So I'll press P to disable it. So now we have the default editor label. Right. So before starting any NPC or AI implementations, make sure your level has these three manager components or three manager instances exist in your level, right? So first one should be the level manager and then NPC manager, and to control the time and all, we have TOD manager. So you can actually find this stuff at the Combat AI system blueprints under managers directory. So simply drag and drop the component like this, so it will be initialized like here. Okay. So now let's look at the enemy AI neutral behaviors. So first I will show you what this enemy neutral AI behavior means. So basically, if you remember, inside the characters blueprint NPC folder, we have our AI behavior tree. So this is the core AI behavior tree, which basically used for most of the combat AI stuffs, such as detecting the target, shooting at the target, flanking, and searching, and such as features such as noise perceptions and all. Right. And there I mentioned this dynamic behavior tree node, where we can actually plug any sort of a dynamic AI behavior tree. Right. So here you can see by default I have been plugged this BT neutral behavior, which is the behavior tree that I'm going to discuss within today's session. Right. So let's go to that behavior tree. So actually it's under AI behavior trees folder. So you can see actually we have multiple different sub trees that can be pluggable to our parent behavior tree. But in our case, now we have to focus on this one, which is BT neutral behavior. Right. So here you can see actually there are 5 main branches, and each has been tagged with a proper blackboard state. So for example, here we added a blackboard decorator which checks for the AI behavior key value as idle. Right? So if it is idle, simply our NPC character is going to wait. And if you toggle AI behavior as roam, then it is going to be wrong, right? So this AI behavior is actually enumerator where we defined at our blackboard. So here you can see we have this AI behavior as an enumeration, and as the default enumeration type, it is added as EAI behavior, right? So you can go and see this enumerator. So actually this defines all the possible neutral behaviors that can be dominated by an MPC, right? So idle is there, roam, follow nearest spline path, from in nearest bounding box, from in point. Such features are there, right? So if you look at the behavior tree, for each of these enumerator key or enumerator value, we have defined a blackboard decorator, and it simply check for that value, and if it is equal to that specific key value, it will perform a certain action, right? So for example, free roam is something like this. Basically it takes a random location within a bounding radius and it simply moves to that specific target. And when it comes to roam in nearest bounding box, basically it first perform a blueprint behavior tree task to actually detect nearest to detect the nearest bounding box, and then it gets a location inside that bounding box and move to that specific target, right? And similarly for the roam in poi, it follows the same thing. So this poi basically stands for point of interest. So we have a dedicated session that cover point of interest features. So I will cover this one in that session, but keep in mind that this roam in poi is somewhat similar to roam in bounding box, but only difference is like that bounding volume will be the range of the poi, right? And finally we have follow spline path, which is basically we can use it for like patrolling features and things like that, and it is implemented as follows. Basically it checks for a nearest spline path and it finds a location to be moved within that spline path, and AI will simply try to move along that location, right? Okay, so that's how we have implemented the behavior tree, and now let's test each of these features one by one, right? So for example, let's say you want to add a stationary NPC or NPC that follows idle behavior. So simply you can add an NPC blueprint. So for this example also I will use the NPC base because it's the parent NPC instance or parent NPC class for each and every individual NPC instances that we have been initialized here. So I will use this base class, then later on actually we can extend it features further, right? So let's drag and drop our NPC base to the level. Okay, so here if you check the combat AI system, you can see its neutral AI behavior is by default wrong, right? And make sure to enable neutral behavior as well, otherwise by default it will not follow any sort of a neutral AI behavior. So for now I will disable these perceptions, otherwise it will actually try to shoot me instead of following this neutral AI behavior, right? So for now I just disable this perception, and at the end of the session or end of this specific part, let's try to enable these three and we'll see how it works, right? Okay, so for now I will make it as idle, and let's play test. So now you can see actually the character is not moving at all, and he's not sensing any perceptions, and he simply remain on the idle state, or more like a stationary state, right? And maybe you can make the character as, let's say, unarmed, by simply toggling the default weapon slot as 0 at the BPC weapon system vector component. So you will see now this is sort of like a idle NPC that exists on the level, right? But let's say if I enable the perceptions and play test it again, now you can see actually he's detecting me because the perception is triggering now, right? But he can't attack me because currently he's in the unarmed state, right? And he's not holding any sort of a weapon, right? So let's enable some weapon as well, maybe pistol, and then let's play. Now you can see actually that character is shooting at me, right? But yeah, so those are basically combat AI features, but considering the neutral AI behaviors, we can use those stuff at here, right? So again, I will disable these stuff because I'm not interested in perceptions right now. And let's open the neutral AI behavior tree and run our game and see how it works in side by side, right? So you can see if I continue now in the behavior tree, now that idle path has been selected, and you can see actually the wait node is being triggered continuously, right? Which is expected because our character is stationary, right? Similarly, let's say I want to make this character free roam in the level. So all you have to do is simply click the combat AI system and select for roam. Okay, and then let's play test it again. So you can see now the roaming path has been selected, and the character waits for some random time, and he is detecting a random location within the level and move to that specific target, right? Actually you can debug and see this location as well. So to do that, all you have to do is simply click on this move to target location node and select this debug location, right? And let's play test it again. Now you can see actually he's trying to detect a random location inside the level, and sometimes the point is too much closer to the character. So in such scenarios actually he's not trying to move, but if it is if the point is considerably away from the character, then the NPC is trying to move. Okay, so that's how you can implement the roaming feature. And let's try this roaming nearest bounding box as well. But first I will make this untick, right? And in order to add those bounding box navigation, first we have to add a bounding box to the level, right? So if you go and see this navigation folder, inside there we have this navigation volumes directory, and there we have this BP bounding box, right? So this is simply a box volume which defines a specific range on the level, right? So we can actually restrict our NPC to move only within this range, right? So as before, like in the free roam, the character is basically able to walk at any point at the location at the level based on the its bounding radius. But if you add a bounding box, this specific NPC will be restricted its movement only within this bounding box, right? So he won't go to this sort of free area, right? So this will be like quite useful when you are implementing like point of interest, such as like maybe like let's say markets or some military base, things like that. So in such sort of interior and no sort of like closed areas, it would be nice to have a bounding box to drive the NPC's movement. Okay. Plus, this bounding box is completely adjustable. So at the setup category, you can see there is a variable called bounding scale. So you can actually tweak these values and adjust its width, height, and other stuffs, right? Okay. And then that's it. So once you add that navigation volume, all you have to do is click on the specific NPC and let's go to its combat AI system and let's make it as from in nearest bounding box, right? So if I play test it now, you can see like from in nearest bounding box feature has been enabled and he's moving within that bounding box. So you can't actually see that bounding volume here. So maybe let's make it visible. You can actually do that by simply clicking on this bounding box and I'll open up its bounding box blueprint, and this is the bound cube that visualize that range. So I'll make it not hidden in game, right? So you can see actually that bounding volume is now visible. If I play now, you can see the character is actually going to the bounding box and he's trying to move within that bounding box, right? Okay, right. And the one other important thing is the NPC is always trying to find the nearest bounding box, right? For example, like here we have added only one bounding box, but let's say I added another one here. But even if I add this one at here, since the NPC's closest bounding box is this one, he's trying to reach to here and roam within this bounding box, right? So if I play it, you will see what will happen. You can see like he's simply trying to move through that specific bounding box instead of going that one, because that's the nearest one. But let's say our NPC is at here, and if I play now, you will see the NPC will choose this bounding box instead of this one, because this is the nearest one, right? But let's say if there are multiple options to be chosen, then the NPC will simply choose a random one, right? For example, let's say if I place my NPC in like sort of a location like this, so you considering the distance, it seems like almost same. So the NPC will simply pick a random bounding box. Right? So you can see like I can't exactly say what will be chosen. So in this scenario, he chose this one. But maybe in the next time, he can choose this one. Right? Okay. So That's about navigation volumes, considering the bounding box. Right. And next, we can discuss about spline paths. Right. So this is a very useful feature in the combat AI system. Like I explained earlier, when you are implementing patrolling features for the enemies, it's nice to have this spline path. Right. So since I don't need bounding box anymore, I will remove these two instances from the level, and let's place an spline path. Right. So simply drag and drop the spline path so it will be appeared on the level. So here you can see there is a point here and here. So this point is basically the origin point of this spline path, and this point is sort of like a adjustable point of the specific spline. So you can actually adjust its length as you wanted. Plus, you can place multiple spline points alongside this spline. So in order to do that, there are multiple different ways. Either you can click on this spline path and add a spline point here, but usually I would prefer to click the Alt key on the keyboard and try to drag one of these axes to place the next possible spline path. So you can see now we have 3 spline paths, spline points actually, right? So maybe I will create a spline path like this, right? So it's sort of like a closed loop. It is not exactly a closed loop, but it is somewhat close, right? And here at the setup category, you can see actually I can set up the direction where the NPC moves. So the NPC can move either forward direction, which means this one, this one, this one, and this one, or it can move in the backward direction, which is the opposite of the spline path movement, right? It can be either clockwise or the anti-clockwise in other way. Yeah. Plus, you can actually debug the spline point placements and the current target spline point of the NPC character. So this would be useful when it comes to the debugging purposes at your development. So for now, since I am explaining these spline paths, I will keep these two as true so I can see how it works on runtime. Right? Okay, so our navigation volume has been placed, and then what I have to do is simply set the combat AI system's neutral AI behavior as follow nearest spline path. Okay. Right. Now if I play, you can see actually the follow spline path branch has been selected. So it will simply run this specific logic again and again. Right. If I continue now, you can see actually there are some white spheres has been appeared within this spline path. Actually that visualize the spline point placement. And you can see a yellow spline sphere or the debug sphere has been appeared within this spline, which is the target location of this spline. You can see the character has been patrolled until the end of this spline, and after that is moving other way around, right? And he's come back to the origin point, and after he's reached the end of this spline, he goes back. Okay, so that's the forward spline path movement, and if you make the spline path's movement direction as backward, then the NPC will try to move from the opposite direction onwards. You can see like he select some random point in the spline and he's trying to move the other way around. Okay. And For now I will make it as forward. And considering the spline paths also, the NPC is always trying to find the nearest spline path, right? For example, let's say if I duplicate this spline path like this, and if I place the NPC maybe near the second spline path, you can see actually he will choose the nearest spline path, right? Instead of going this way. And maybe let's duplicate our NPC as well, and let's place two NPCs alongside two spline paths. So by theory, this NPC should choose this spline path, and this one should choose this spline path, because those are the nearest spline path for those NPCs, right? So let's play test and see. Okay, you can see they are trying to reach their nearest spline paths, and their movements are completely isolated, right? So they are not actually going to the spline points of the other splines, right? Instead they are following their own spline path, right? So you can actually use this feature to implement like patrolling NPCs, maybe guards, things like that. Okay, right. I think those are the features that I wanted to cover in the neutral AI behaviors, but I intentionally haven't explained this part, which is from in POI, because as I said before, I'm going to explain this stuff at the POI section, right? Point of interest section, right? So actually I have been added sample demo levels as well to showcase these neutral AI behaviors. So if you go and check the demo levels, here I have been added AI free roam example, AI roam in bounding box example, and AI patrol example, right? So these are actually somewhat demo levels which pre-integrated or pre-constructed showcase levels that demo these features that I just explained, right? So you can go and see some of its features, like for example things like that. Okay, so in these levels actually these NPCs have enabled the perceptions as well, right? So you can see actually once they detect me, instead of following the neutral AI behavior, they actually trigger in their combat AI behaviors, right? And maybe you can go and check patrol example as well. So that's also same, right? So here you can see like they are currently following the neutral AI behaviors because they haven't detected me. But let's say if I detected, then instead of following their neutral AI behaviors, they are trying to shoot me, right? Because that's their combat AI behavior. And let's say if I get away from them, after a while, they will go back to their neutral AI behavior. Right. You can see like they are still flanking, but I think probably they will detect me because the distance is not long enough. So in case if they detect me, they will shoot. Otherwise, they will follow and do the neutral AI behavior. So here you can see like this NPC has been detected me, so he will simply shoot. But this one haven't detected me, so he simply go and do its plain non-neutral AI behavior, which is patrolling. Okay. You can see like he's go to its spline path and he is patrolling again. But this guy is keep shooting at me because he is still at the combat AI behavior because he is detected an enemy. Okay, right. So those are the features that I wanted to cover considering the neutral AI behaviors of the combat AI system. So that's it, and I'll see you there. Thank you.